Section 2.1 is on representing integers. To start, an integer is any number that can be represented without using a decimal or a fraction. So in this case, we'll look at 23. 23 is an integer, while 4.7, for instance, would not be. It isn't an integer because it has a decimal and is not a whole number like 23. 23 is just a number. It's a whole number, no decimals, no fractions. So it's an integer. While 4.7 is not a whole number, it's four whole numbers and 0.7 of another number. So 4.7 is not an integer. Moving on to the two different types of integers, we have positive and negative. Above 0 would be positive. So in this case, I chose Death Valley. Death Valley has the highest ever recorded air temperature there of 57 degrees Celsius. So that's above 0, so that would be positive 57 degrees Celsius. While on the flip side of that, Antarctica has negative 57 degrees Celsius. So they're complete opposites. The higher temperature, or the hotter temperature, was positive 57 degrees, while the colder or lower temperature was negative 57 degrees, both below or above 0. Representing integers, there's numerous ways that we can do that. One of the easier ways to do it is with tiles. Now, in this case, we use red and yellow, yellow being the positive and red being the negative. When you bring out two tiles, right now, technically, I would be representing positive 1. I have one positive tile. If I were to then bring out a negative, I would then be dealing with 0. I now have 0. Negative 1 and positive 1 cancel each other out to make 0. This right here is called a zero pair. These two right there together are called a zero pair. They cancel each other out. Negative 1, positive 1. If you add them both together, they make 0. So in order to show that for positive 5, I can easily go 1, 2, 3, 4, 5. I have 5 positives and no negatives, meaning I've made positive 5. If I brought out every negative, so if I brought out 2 negatives, these now cancel each other out, and I'm just left with a positive. These cancel, and I'm left with positive 3. But to make positive 5, I would need to bring out 2 more positives. So now I have 7 positives and 2 negatives. Positive 7 plus negative 2 equals positive 5. Let's look at that from a negative perspective, the negative standpoint. Again, I have negative 3. So right now I can bring out 1 and 2 and 3. So now I have negative 3 modeled there, 3 negative tiles, no positive tiles. If I bring out some positive tiles, I need to cancel those out. A positive and a negative cancel each other out. Now I'm only sitting with 1 negative. So to make negative 3, I would have to bring out 2 more negative tiles. So in total, I have 1, 2, 3, 4, 5 negatives and 2 positives. Negative 5 plus positive 2, these cancel out. It gives me negative 3. And for another example, positive 1, very straightforward. It's the lowest number we can get. Pretty much the lowest integer or whole number we can get. So in terms of 1 being the number we're using. So positive 1, really simple. I've brought 1 tile over. If I bring over a negative tile, I'm now at 0. Negative 1 plus positive 1 equals 0. So I have to bring over another tile. And for every negative I bring over, I need to bring over another positive to make sure that I've made positive 1. So again, I go through, and for every negative, I cancel a positive. 1, 2, 3. I am only left with the 1 positive there, positive 1. 4 positives plus 3 negatives still equal positive 1.